Okay, welcome back. And now what we're going to do is we're going to talk about derivatives, taking the derivative of a function using logarithmic differentiation. And you've seen me do this in one of the problems. So it's by using the logarithmic properties, the properties of logs, in order to expand out a complicated looking function in order to make it much simpler to take the derivative of. Okay, so this is a common technique because up to this point we know how to take the derivative of a function like this, where we have a function raised to a power for certain values of n, right? Typically what we're looking at is integers. And we also know how to take exponentials, write derivatives of exponentials where we have b to the g of x, where b is greater than 0 and not equal to 1. But what about these functions where we have x to the x, or y equals x to the pi, where the exponent is an irrational number? We don't know how to deal with those, okay? So what logarithmic differentiation allows us to do is it allows us to be able to differentiate functions of the form of y equals g of x to the f of x, right? Of those forms, okay? Or very complicated looking functions that we then can use the properties of logs to break down, expand, and then deal with more simpler pieces, okay? So here is the strategy that we use for applying logarithmic differentiation. So first, you take the natural log of both sides of the equation, and so you'll get something that looks like this. Natural log of y equals the natural log of the function that's given. And then you're going to use the properties of logs to expand this log of h of x as much as possible. So we're going to do that as much as possible. I apologize, I'm having some work done here, so bear with me. So then step 3 is we're going to differentiate both sides. Okay? So after you expand the one side using the properties of logs, then we're going to differentiate both sides of the equation, and that's going to give us 1 over y dy dx on the one side because of this right here. Okay? Now, because of this one right here. So if we take the derivative of this, we're going to get 1 over y dy dx. Okay. Then step 4 is solve for dy dx. Okay. And we're going to do that by multiplying both sides by y. And then after that, once we solve for dy dx, then we're going to replace y with h of x again, just like we did before in that past example. I didn't say anything about logarithmic differentiation, but that's what I was actually using in that previous example. So now you know. So this is actually called logarithmic differentiation, and it's used to handle some complicated looking functions. So let's do some examples now. Have a great day.